Hello, hello. So, los geht's? Wir machen speak English first, okay? So, we're gonna code our project for today. And it is a guessing game. Does seem to be very easy. Okay, so we could go straight forward to the demo. Okay. Real quick. Click the demo. This seems to be an easy project, so my guess is gonna be, first of all, I'm gonna choose the difficulty, which is easy. Okay, it seems to go too hard if you didn't type easy, which is weird. Make a guess. It's gonna be 40. Low, what about 70? Too high, 60. Too high, 50. Too high, okay, 45. Okay, too high, you got it, the answer was 45, okay. Cool. So, it is that simple. So I guess, okay, global constants, etc. Okay, beautiful. So yesterday we have learned about global constants, global variables, and block scope. And now we're gonna make our project. So first of all, we're gonna have this ASCII copied. Okay, type something, okay. I call it guess the number. Okay, we're gonna choose 3D. Yeah, this seems fine. Guess the number. Beautiful. We are gonna print all of this. Okay. Beautiful. That's done. Okay. Could actually remove this escape character by, okay, I don't know how to escape it. Okay, like this. Beautiful. Beautiful. So this is our first ASCII that we are going to print for the game. And second of all, we're gonna import random because we're gonna pick a random number. And we're gonna need a list of numbers. So number list. It's gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. We're gonna do a for loop for this. So for integer in range of 100. Yes. We're gonna guess a random number from this. And okay, let me print these variables and see what's gonna happen. Guesses, and let's print as well. Guess. Beautiful. Okay, that's it. Let me see what's gonna happen for this. Okay, for the ask we have some of these letters that are not functioning. For that reason, I'm just gonna comment it out. Until later, I'm gonna troubleshoot that, okay? Okay, beautiful. So here we are picking a random guess. And for that reason, I'm not gonna need this for loop, is it? So we are picking a random integer from 1 to 100. This one is enough, I guess. Okay, let's see. Yeah, so this picks up a random number. Beautiful. So we're gonna define a function that pick this function is gonna pick a number, and okay, perfect, print instructions number. Okay, and we are going to return that number exactly. You know, small function that does the work for us. Beautiful. Then we're gonna make another function called hint, right? Or before that, we're gonna just make another function called difficulty. Yeah, beautiful. Okay. I guess I have a spelling problem in here. Let me just make sure of that. Okay, I need to add interrupt difficulty with this manner. Yeah, who cares? Okay, beautiful. So we're gonna have a variable called choice, maybe difficulty choice, and we're gonna make an input for this. Choose difficulty, for example. It's gonna be easy or hard. Beautiful. And we're gonna make it dot lower. Okay, so if difficulty is easy, we are going to return how many attempts if it was easy. Let me see the demo. Okay, I'm gonna choose easy. We're gonna have 10 attempts. We're gonna return 10. And if difficult was hard, we're going to return 5. Yeah, that's true. Okay, so this seems to be functioning as it's supposed to be. Okay, and we're gonna define another function called hint. Okay, beautiful. So this hint takes an input called the number. Okay, and through this input, if the number actually was we're gonna need player input as well, which is the guess. Okay, so we're gonna need 2 inputs, guess and number, which is choosing random number. Okay, so if the player guess was maybe bigger than the number, then we are going to print guess too high exactly. LF, if the guess was actually smaller than the number, guess too low exactly. And else, which is if the guess was equivalent to the number, we're gonna print correct. Beautiful. So this is the last case. Okay, so these are our functions. Beautiful. So we are using this function to pick a random number. We are using this function to choose the difficulty. and through that we are having our attempts. Okay, so we're gonna make a while loop and deploy our functions. So while attempt, so the attempt, we're gonna just call our difficulty function. So attempts, we're gonna call the difficulty, then difficulty is gonna give us the attempt as a return. So while attempts are not equivalent to 0, okay, exactly. So each round, each guess that, okay, I'm gonna make this in this function. So so we take the guess, the number, and then the attempts as well. Attempts, beautiful. So if it was too high, we are going to minus these attempts as well for this case, and otherwise it's gonna be just correct. Beautiful. Okay, so the first thing, we are going to pick a random number. We did it here. Second, we are going to know the difficulty. So yes, we did that, and we need to pick a random number. So let me just random number. Yes, rather that we have a function, so we don't need to do that. Just big number. Beautiful. This is gonna return to us the random number. Okay, and then we're gonna use this, which is the hint. So we have the guess. So we need a guess. Okay, beautiful. So we need the guess, we need the random number, and we need the attempts. With all of them we have. So guess input, guess a number between 110. Beautiful. That's correct. Okay. And then here we have the hints. Because the hint takes these inputs. It's gonna take the guess. It's gonna take the random number. It's gonna take the attempts as well. Beautiful. And this should do the work for us. And just like that, we did it. Okay, beautiful. From this print. Okay, beautiful. Okay, so we could copy this and paste it to AI through this ASCII, because there is some error with it. I'm gonna ask AI solve the error of this ASCII if it gets interpreted by the Python compiler. Okay, let's see if that's gonna go. Okay, this takes a little while. It does take a little while though. It's okay. It's thinking, formulating the solution, examine the code's behavior, determine the best approach, finalizing the recommendation. Okay, beautiful. Okay, so this ASCII should solve our error. Let's see how it's gonna look like. Beautiful, let's see. Okay, so let's launch the game. Okay, so it's gonna ask us about easy or hard. I'm gonna choose easy. This is gonna give us okay, if we choose in the difficulty, we should know how much attempts we have. Okay, so I'm gonna add it to here. So I'm gonna print Okay, let's continue. So if the difficulty was easy, then we're gonna print how much we are going to return in this case, which is gonna be 10. Okay, and we're gonna print another string. This could be inside of the string, no problem. Okay, you have Maybe it's gonna be way better if I assign this to a variable. So attempt, it's gonna be 10. Then I'm gonna return the attempts. Beautiful. I'm gonna use an f string and curly brackets and output that. So you have attempts, and I'm gonna type good luck. Beautiful. Okay. And we're gonna return that, and the same is gonna go for here, which is the easy path. It's gonna be 5. I'm gonna return that. Yeah. Then I'm gonna print something like this. So the same thing. Good luck. Then I'm gonna type a new line. I'm gonna type next time. We need to define that as a new line for the interpreter. So next time, choose the hard difficulty. Beautiful. Just a little hint, you know, because you are used to the game, so there is no more of that. Okay, so if the attempts were lower, then we should make a print statement, or we could just return that as a string. Okay, no problem. No, print statement is gonna be way better in this case. You have attempts. Okay, you have this attempts left. Do not give up. Okay, so we're gonna have the same print statement over here. Beautiful. So this is the game actually. Pretty easy to develop. Easy game. So easy difficulty. So we have 10 attempts. Good luck. Okay, I'm gonna choose number 78 maybe. Then we're having an error. Oh, because okay, so my input. Okay, let me check my input. I have to hold on a second. Yes, here my input should be an integer. Okay, this is a very stupid error, easy to fix. Okay, beautiful. It could be a float as well, but let's keep it simple. Use integers. Okay, let's type here easy. I'm gonna choose 40. Okay, it's too high. We have 9 attempts. Okay, what about 30? Too low. Okay, what about 35? Too low. Okay, what about 38? Too low. What about 39? It's too low. And 40 is too high. Interesting. That's kind of interesting, isn't it? Okay, what about 41 is gonna be too high. No. That's weird. It's too high for 40. And it is too low for 41. This doesn't make any sense. And 40 is gonna be correct. What? I typed 40 before. I don't get it. Okay, if it was correct, we are going to break the while loop. Okay. Was how to do that. Maybe we could do a little variable Or we're gonna return a value. Return we're gonna return false. Maybe. Or if so this send statement is gonna return to us false. Maybe we could return I don't know. Maybe false. Let me try that. If the output was false, let me see that if we found the integer. Let me use easy. So we have to attempt. Okay. I'm gonna choose 20. Let's see. Too low. 60. Too high. 40. It's too low. What about 50? Too high. What about 45? Too high. What about 43? Too low. Okay, here doesn't make any sense. Okay. And then we have 9 attempts forever, which doesn't make any sense. It's kind of weird. The code behaves in a weird manner. Maybe it is this else statement. So I'm gonna make an elif. Elif gets equals to number. Okay, maybe that was the problem. Okay, let's see. Easy. Okay, let me choose 20. It's too low, 40. Too low, 60. Too high, 50. Too low, 56. 57. Too high. Like this doesn't make any sense, and the attempt does not get lower. And this is problematic. Like we should actually make them smaller, but that doesn't work as it's supposed to be, which is weird. I don't know. For this doesn't make any sense. We could just make here an if statement. If maybe we could assign the output of hint to a variable. Maybe. So if hint yeah, we could do that. Why not? Let me store the output of the hint in a variable. It's gonna call that the results. Okay. And after that, if the result was equivalent to false, then we are going to break. Okay, like this. Beautiful. And this would execute the code as it's supposed to be. No, not a single difference. Yeah, it executes. Okay, for the attempts, they don't get lower, which doesn't make any sense. Like, why does that not function? Should I assign the attempts as maybe here as an empty attempts? Yes, 0. If it was equivalent to 0 exactly. Maybe let me make that into hundreds and do this again. See if that functions. We have an existing code. Interesting. that doesn't function. Okay, let's see. So if the attempts are 0, not doesn't equivalent to 0, that will not make any sense. That was stupid for me, okay. If the attempts were equivalent to 0, then we should break the while loop. Let's see. Okay, I'm gonna choose easy. Doesn't even work this time. You have 10 attempts, good luck. There's a problem in here. No, that doesn't make any sense. That doesn't make any sense. Okay, while the attempts are not equivalent to 0, which makes maybe attempt is maybe 10, okay? And this is not equivalent to 0. But in the case if it was equivalent to 0, it's gonna break the while loop. Okay, just kind of the opposite. Okay, beautiful. Let me choose easy. I'll choose 1. We have 9 attempts left. But that doesn't get lower. I don't know what's the reason for that. It's kind of weird. Okay, let me run that through Thorny. See why this happens. Okay, I'm gonna output Thorny, see where's the bug at. Maybe it's a weird bug, who knows. Let's paste this in C. Okay, I'm gonna just skip all of this. Okay, so we're gonna choose easy as difficulty. And enter that, is gonna give us 10 attempts. And we're gonna return this value. So while attempts are not equivalent to 0, I'm not gonna break this while loop. Okay. And we're gonna pick a number, beautiful. A random number, so it's gonna be 24 in this case. Then we're gonna return it. Beautiful, it works like butter. And assign it to the random number, okay. And then here we have this variable that asks us about our input. We'll choose 1. Okay, so that's our input. It's gonna be transformed to an integer. Okay, so our gate is gonna be 1. The random number is gonna be 24. The attempts are gonna be 10. So here we have an error at the attempts. Let's see, where's the bug at? Okay, so if 1 is bigger than the number 24, okay, so in this case it's not bigger, it is actually smaller, so we're gonna execute this one, which is true. I'm gonna print this to the console. It's too low, and then we're gonna make the attempts to 9. That functions. Yeah, right. Exactly. So we have 9 attempts left. Beautiful. Maybe the error because we don't return the attempts. Okay, let me see how this could work. Okay, beautiful. So in this case, I don't return this value of attempts. That's why there is this error. So we're gonna return these values. Return attempts, beautiful. And with this, it's gonna be solved, I guess. So let me see. Choose easy. I'm gonna choose number 1. Number 2. Nah, it didn't work. Weird. Kinda weird though. This output gives me the attempt. Let me rename this result to the attempt. See if that functions.
Hey bro, give me the motorbike.
Okay, so it seems that this bug doesn't want to get solved. So let's see where's the error at. Oh my god, like I did everything. It's not getting. I'm getting a none. Okay, no problem with that. Okay. So we are getting a none out of that. Okay, no problem. Oh my god, I'm stupid. I'm stupid. I should have, because this is a global story. Sorry. I'm just gonna go here. This is a global. I've learned about the scope and I didn't care about that. So first of all, I'm gonna use this global to actually edit this variable, and I don't have to edit it anymore. So yeah, beautiful. Why do we have an error in here, eh? It may be a typo. No problem. Why do we have an error? Why? Maybe we could do that at the beginning in here. And yes, don't have to use this input because of that. Okay, beautiful. Okay, so this should eventually work. Okay, and if we got false, then we're gonna break, or if the attempts, I'm gonna call this not a test but results. Okay, the results, rather than false, I'm gonna use true. Okay, beautiful. Yeah, I'm gonna use result. Beautiful. And while the result is not true, and while the result is not true, is not true. Yes. Okay, beautiful. Beautiful. So if the result was equivalent to true, then we're gonna break. Let's see how that works. Okay, I'm gonna choose easy. Okay, so we have 10 attempts. Let me see. 30, too low, 50, too high, 40, too high, 35, too low, 34. Correct. Okay, so we didn't break. We didn't break that, even though this should have returned to us true. That should have been saved to result. I didn't play with that. Okay, no problem. I'm gonna delete this. Okay, if this variable gave us true, then we are gonna break that. Beautiful. Let's see, that's gonna go in function. Here's easy. And choose 40. Okay, too low. What about 50? Too low. What about 60? Too high. What about 55? Too high. What about 54? So 55 is too high. Doesn't make any sense. 55 too low. 56 too high. This doesn't make any sense. But why? I don't know. Because each time we are picking a random number. Okay, that's why. Okay, I'm gonna define this outside of the while loop. Yes. But yes, I'm gonna define it outside of the while loop. Let's see how that's gonna go. Maybe that was the error. Let's see. Easy. We have 10 attempts. What about 30? Too low. 40. Too low. 50. Too low. 60. Too low. 70. Too low. 80. Too low. What about 90? What about 99? Too high. 98. Too high. 97. Too high. Interesting. So we have 0 attempts and the while loop has been broken. Okay. It's easy. What about 89? Too high. 70. 50. Too low. What about 70? Too low. 80. Too high. 79. Too high. 78. Too high. 77. Too high. 76. Too high. 75. Too high. 74. Correct. Okay, beautiful. So finally, because the while loop was picking each time a random number, maybe we could do that if the difficulty was hard. Each time we're gonna have a random number, maybe. So for that case, I'm gonna break all of this. I'm gonna delete all of this, I guess. So I'm gonna go and say and input this as difficulty. Beautiful. Yes, exactly. Then we're gonna use this. We're gonna need the hint as well. We need the guess and the random number. Get rid of that. Yeah. Okay. So if the difficulty it's not a function, by the way. If the difficulty was actually equivalent to this return value, which is let me see this. Global if guess was equivalent. Difficulty, attempts difficulty. Oh yes, so we're gonna need this function actually. I'm not gonna use the hint function. Okay, over here. I'm gonna store that using this difficulty function. Beautiful. So we are going to return difficulty choice. Okay, beautiful. Interesting. Okay, maybe for later. So the game functions just fine. Okay. There is no need of this. Beautiful. So we have, our attempts, our random number, everything is working just fine. But I had an idea of if you have chosen the hard difficulty, we are going to have a random number each time. Each time you guess a number, that random number is gonna change. It's gonna be more difficult. Okay. And because of that, I could just maybe store your choice and return it. So I'm gonna return the difficult choice as well as the attempt. It's gonna be way easier like this. Difficult choice, beautiful. Okay, So after I am having this difficult choice, I'm gonna use this X and Y. I'm gonna call the difficulty over here. And then if Y. Y is the difficult choice, right? Yeah. So if Y was equivalent to the string, which is easy, then we are going to have this while loop like this. And for that reason, I'm gonna need to call this as so. I'm gonna recall this X as attempts. Okay, attempts. Beautiful. And Y is like the difficult choice. I'm gonna use it as Y or change the name of it. No problem with that. I'm gonna call this difficult choice, and I'm gonna copy this, paste it in here, so the code is more readable. If that was the case, we are not going to pick a random number each time. We are going to pick it before the while loop, else else is enough, so we're gonna use else. We are gonna go and have this while loop, and we are going to pick a random number each time. Okay, each time you fail. Beautiful. Okay, I'm gonna paste it in here. Beautiful. So that's the difference between these two while loops. Okay. Yeah, so that's the difference. Beautiful. Beautiful, beautiful. Okay. What should I add as well? I should add to this function. If you choose the easy route, so I'm gonna say the guess. Okay, I'm gonna need a new line. The guess does not change if you failed to guess the number. Beautiful. And here I'm gonna say good luck. Okay, hold on a second. Why did I input this? That doesn't make any sense. Okay, I'm gonna type this over here. I'm gonna get rid of this. Beautiful. Okay, so next time, choose the hard difficulty for. I'm just gonna leave it simpler. Okay, the guess does not change if you failed to guess the number. So it's not the guess, it's actually the random number. The random number does not change if you failed to guess it. Okay, beautiful. And here I'm gonna have I'll just delete this real quick. Okay, beautiful. So you have this type of attempts. Each time you fail to guess the random number, then the random number is going to change. Okay, and like that, the hard difficulty is gonna be super hard because each time that random number is gonna change. Okay, beautiful. I'm gonna need some new lines for each of these over here. New line, and another new line. beautiful. Okay, let's see how the game's gonna be like. So I'm gonna choose the easy route for the moment. Okay, you have 10 attempts, good luck. The random number does not change if you fail to guess it. Next time, choose a hard difficulty. I'm gonna choose 40. Too high, what about 30? Too high, 20. Too high, 10. Too high, 8. Too low, 9. Correct. And that was the easy route, so it is easy. Here we have the hard route. We're gonna have only 5 attempts. Each time we fail to guess the number, that random number is gonna change its value. Okay, we should make it super hard. So I'm gonna choose 80. Too high, what about 60? Each time it changes, so it's super random. 30. Too high, 20. Too low, and the code has finished because the number of attempts was more than, okay, how much? Okay, so this is our first attempt. 2, 3, 4. Okay, we still need to have one more attempt, but that didn't seem to happen. Interesting. Okay, so the project is done and the hard difficulty is almost impossible without cheating. Okay, for this reason I'm going to cheat. So I'm going to print the random number, and I'm going to see if the random number changes each time. So this time it's 87. It doesn't change. No, it does change. It does change. Now it's 5. Now it's 64. Okay. Let me try this again. The hard route is 52. 22. Yeah, it does change each time. That random number changes, which makes the game very hard. Okay, super. So I'm gonna take a little break and I'm gonna get back real quick. Okay, so we're back. Let's get more of this done. So this project is done for the moment. So we're gonna go and watch the motivational video. Beautiful.
Well done on completing day 12. Now, one of the things that I really want to say to everybody is don't be so hard on yourself. Because I know that I do it too. You know, sometimes your inner voice says like, oh, I can't believe you missed a day. Or like, why couldn't you get the answer the first time? It doesn't mean that you failed. As long as you keep trying, you're succeeding. So don't worry if you've missed a day here or there. Don't worry if you had to do one day in 2 days, or if you didn't get the solution straight away. As long as you keep going at it, you're going to succeed eventually. And remember, I believe in you.
Okay, that's fine.
Hey guys,
Okay.
welcome back to 100 Days of Code.
So here we're gonna learn about debugging. Debugging, how to find and fix errors in your code. Okay, cool.
Today we're going to look at debugging, the process of removing bugs from your code. If you managed to get to this point, you've probably written quite a bit of code already. And I will bet that you've probably made some mistakes, some typos, some errors, and some bugs. So in this lesson, I want to talk about some techniques and tips for how to find bugs and how to get rid of them from your code. Now, the first documented bug was actually found by this lady, Grace Hopper. She was probably one of the first programmers and one of the pioneers of...
Wow. But the first programmer is a man, so doesn't make any sense.
the job that we're undertaking right now. Now, in her notes, you'll find a moth that's been taped to the notebook. And this was found in a relay that was preventing her code from running properly. And this was pretty much the first actual case of
an error, which is a bug.
a bug that's been found in a computer. Even though we're not dealing with moths these days anymore, we're still going to end up finding bits of things in our code that prevent the code from doing the things that we want it to. The important thing to remember is don't feel down when you've created a bug, because everyone gets bugs. And when I say gets bugs, I mean we create them, right? So once you've gotten over this, next I want to talk about some of the tips and techniques that you should follow on how to quickly be able to identify and remove these bugs. So the first step is to describe the problem. If the problem is messy and it's not well understood in your head, then it's almost impossible to debug it.
Okay, so we're gonna take notes about these stuff. The first thing is gonna be to describe the problem. Okay, that's interesting. I'm gonna copy this real quick, the clipboard. Then I'm gonna go to our Notion, and I'm gonna add a page. I'm gonna delete all of this. Okay, beautiful. So we're gonna add a page over here. Come on, not a toggle. I meant a page. Okay, beautiful. And we are going to talk about how to identify a bug. We're going to upload this image. Beautiful, beautiful.
So untangle the problem and try to make sense of what's going on. Now, in this block of code, we're going to practice describing the problem to help us solve this debugging problem. Now, if you take a look at this function, you can see that at some point in the function, we're supposed to print this line out into the console. But if we go ahead and hit run, you can see that nothing gets printed. So what's going on here? I want you to take a look at this function and describe the actual problem.
Okay, so for an integer in this range, if this integer is equivalent to 20, Then we're gonna print you got it. So this is a for loop, and we are taking like 1, 2, 3. This is the last thing. At least we should print you got it even once. But that doesn't seem to be the case. Okay, let me troubleshoot this. Let's go to the next line. Okay, I think we should for at least define this. At least. See how's that gonna go for? Still not done. Okay, interesting. This is a weird bug. What if it was equivalent to 20? So let me go to Thani, because at least we're gonna have this integer equivalent to 20. Oh, I get it. Maybe we're gonna need to add 1, because it's a computer thing, because in computer we start the counting from 0. Okay, 0 and 1, etc. Okay, so maybe that was the bug. Yeah, correct. Otherwise we could start this from 0 to 20, then we're gonna have the same result, I guess. Nah, 21. Yes, so we start the count from 0 until 21, and 21 is actually the 20. Okay, so this case is out of range. That was the reason for it. Pretty easy.
What is the for loop doing? When is the function meant to print you got it? What assumptions are you making about the value of I? So pause the video, read the function, and have a go at describing the problem. Alright, so what we've got here is we've got a function that loops through all the numbers between 1 and 20, and then once that number reaches 20, it's supposed to print you got it. But the problem is that when I reaches 20, it doesn't print this line into the console. So now that we've described the problem and we understand what's going on, let's see if we can solve it. If we think about this problem, when I reaches 20, it doesn't print out this line. There's an assumption in there, right? The assumption is that I will definitely reach 20. But if you think back to how the range function works, the stop or the upper bound is actually omitted. So when you write range 4, it actually produces a number from 0
to 3, exactly. So that's the case. That's how we count 4 in Python, from 0, 1, 2. So 1, 2, 3, 4. So 0 is counted as a number and not as nothing, okay?
up to 3. And in our case, when we write 120, it actually goes from 1 all the way up to 19, but not including 20. The problem here is that I actually never reaches 20. So this assumption is completely false. Pause the video and see if you can fix the code so that this line actually gets printed. All right, so
we did it.
All we need to do is change this to 21 instead of 20. And now when we hit run, you can see it actually works and we managed to debug this problem. Always, when you come across a problem in your code, try to describe it so that you really understand what the issue is, and then test your assumptions and see which of those assumptions is actually false.
Okay, beautiful.
Now, the next step is to think about reproducing the bug that you've encountered. Because when you encounter it once, but you don't encounter it the next time, that becomes a really difficult bug to fix. In this section, we're going to try and reproduce the bug. So when we run the code, sometimes it will work and it will print out one of the dice images.
Okay, let's see this challenge. It's more of a bug challenge. Okay, so our having this list that has this ASCII as numbers, and we are taking a random integer and adding to here. So this is the index of this list. So we are taking a random one. Okay, so we are taking from 1 to 6. Okay, that's problematic. Okay, it should be because if we ran this, we're gonna get an error. It's gonna be out of range. Okay, let me check this error real quick. Yeah, so error list index out of range, as I said. So I should reduce this by one number, because we are taking from 1 to, which is 0, 1, 2, 3, 4, 5, and 6. Okay, so rather than doing this, I'm just gonna comment it out real quick. I'm just gonna go and print the dice number like this, and like this as well. Beautiful. Let's see, so we have 1, 1, 4, 2, 2, 0, 1, etc., etc. And we should start the count from 0. Okay, because we want the integer 0, because we are talking about indexes. So this one is gonna print to us this one. Okay, 4, 5, etc. Beautiful. So this one is 0, 1, 2, 3, 4, and 5. So 5 is actually the limit, because we are starting the count from 0. Okay, okay, beautiful. And then we could just comment out this, and I'm not gonna have any error anymore. So no matter how much we run this code, it's gonna function as butter with no any problem. Okay, not a single problem. So the bug is fixed. It was very easy.
From this list, but occasionally you will get an error. These types of bugs are really difficult because you might test your code only once or twice and it looks all fine, it works, but then occasionally you get an error. And the important thing is to reproduce that error. When does that error actually happen? And based on that knowledge, we can fix our code. Try to reproduce the bug yourself and try to notice when it happens and see if you can change the code so that it always produces this error.
Okay. Okay. Beautiful. So rather than, because this is a very simple error, to actually make it reproduce this error all the time, we could just choose from 6. It doesn't make any sense. We're gonna have another error because this function takes at least a range of 2 numbers, so 6 and 6, and by that we're gonna have this error produced all the time. You see, all the time it's gonna be produced. Okay, as simple as that. Otherwise we could just fix it by having an index that is defined in this list. Okay,
We've got a list of dice images, which are just emojis, and we've also got this random number, dice number, between 1 and 6. Now, when we try to pick out of our list, occasionally we get an error. Now, we have to notice when the error occurs, and to reproduce the bug, we have to figure out which of these numbers is actually causing the problem. So we know that this is a random number between 1 and 6, And if we check the documentation, it tells us that randint works a little bit differently from range. It will return a random integer in the range of A and B, including both endpoints. So in our case, both 1 and 6 could be generated.
Exactly.
And it could be any number. So if that was equal to 1, well, does it generate an error? No, it just picks out this particular item. But what if it was 2 or 3 or 4? Or what if we tested 6? Well, now every time we hit run, you can see we get an error. And now that we've got our error to show up consistently, it's a lot easier to debug, because we know that the index error, list index out of range, happens when this dice number is 6. So when we go back to our previous code, well, we can't use 6 in this list because lists start counting from 0. So to get this dice 1, we need dice num to be 0. And then this is 1, 2, 3, 4, 5. And 6 is somewhere out here and it doesn't exist.
Yeah, because the count starts from 0, true.
Now go ahead and fix this code so that all the dice...
It's so freaking basic. Okay.
Now the next step...
Here we are having... So, first of all, we should describe the error. Second of all, we should reproduce the error. Interesting. Gonna have that noted.
Step is to think about reproducing the bug that you've encountered. Because when you encounter it once, but you don't encounter it the next time, that becomes a really difficult bug to fix. In this section, we're going to try and reproduce the bug. So when we run the code, sometimes it will work and it will print out one of the dice images from this list, but occasionally you will get an error. These types of bugs are really difficult because you might test your code only once or twice and it looks all fine, it works, but then occasionally you get an error. And the important thing is to reproduce that error. When does that error actually happen? And based on that knowledge, we can fix our code. Try to reproduce the bug yourself.
I did that as well, so yeah.
And try to notice when it happens and see if you can change the code so that it always produces this error. We've got a list of dice images, which are just emojis, and we've also got this random number, dice number, between 1 and 6. Now, when we try to pick out of our list, occasionally we get an error. Now, we have to notice when the error occurs, and to reproduce the bug, we have to figure out which of these numbers is actually causing the problem. So we know that this is a random number between 1 and 6, and if we check the documentation, it tells us that randint works a little bit differently from range. It will return a random integer in the range of A and B, including both
Endpoints. Oh, so we have watched this before. There is no point of repeating the same video. So let's move on.
Very often, I've asked you in the quizzes especially to play computer. And the reason is because this skill of pretending to be a computer, reading through your code and imagining what you're going to do each time is really, really useful, especially when you're debugging. Take a look at this code. It takes an input in the form of an integer and it asks the user for their year of birth. And then it uses an if statement to check if they were born between 1980 and 1994, in which case they're classified as a millennial. But if they were born later than 1994, then they're classified as a Gen Z.
Okay, so there is no problem in here. We could actually make an encadrement in here. It's like a math kind of thing. It's pretty easy to do. So what's the bug in here? There's any bug? I don't know. What about if we included a year below the range? Nothing happens. Expectable. I could, rather than using this end statement, it's unnecessary. Could make the code a little bit more elegant. Okay. Beautiful. So this does the same. Yeah. Not a single difference though. Okay. Okay, beautiful. So in this range, for example, I have inputted this, I am Gen Z. Or if I have inputted this, I'm a millennial. There is no bug in here. Okay, so it takes the inputs, it compares to these values. If it was inside this, what you call that in English? Range between this year and this year, then you're a millennial. Otherwise, if the year was superior than this year, then you are Gen Z. That's a little bit stupid, isn't it? The computer go through the code line by line as if you were executing the code to figure out why. So for example, for this year, 1987, which is inside of here, so this is going to return to us true statements for this case, and then the interpreter is going to execute what is intended in this if statement, and it's going to output to us a prompt, and this prompt has this string, and that's exactly what happened, okay, in here. Same thing goes for here. If this was false, then we're going to move to this second condition, and if it was true, then we're going to execute what has been intended in this. Okay, simple as that.
So depending on which country you're from, there's different classifications for your particular generation. This is just the typical words that you hear on the internet. You're a millennial, you're a Gen Z, you're a baby boomer, and this comes from a lot of the history of the US. But nonetheless, I want you to run the code, and I want you to see what happens when I put in 1994. Absolutely nothing. So we have our bug right there.
Oh, come on, man. That is a stupid bug. Okay, is 1994 expected to be a millennial or a Gen Z? Maybe it's a millennial. And that should function as it's supposed to be. Like, this is a very silly bug. Doesn't make any sense. Okay.
Run through the code line by line and evaluate each statement, and follow the logic and check what it will evaluate to. So I want you to play computer and figure out what is the problem, and then go ahead and fix the bug. Pause the video now. Alright, so let's pretend that we got 1994 as the input. So now I'm the computer and I know that this year is equal to 1994.
Okay.
Now, with this year being equal to 1994, I go into this if statement. So is 1994 greater than 1980? Yes, it is. So this actually becomes true. Now I have to check the second condition, and it also has to be true for this if block to be triggered. So is 1994 less than 1994? No, it's not. It's actually less than equal to 1994, or it's equal to 1994. So in this case, this condition becomes false. And we know that if we try to combine a true and a false, then it actually just becomes a false. So this gets skipped. Now next, we look at the next statement, right? if 1994 is greater than
This is so much stupid and basic, so we're gonna just skip it. 4 minutes, waste of time.
Now, the next step and the next tip is pretty obvious. When the editor is giving you an error or when the console is giving you an error, fix the errors before you continue. Now, this is a little bit easier when you're dealing with errors in the editor because it'll actually highlight to you the line that's broken. So here we've got a print statement, and when we hover over it, it tells us that it expected an indented block. So that should be a good enough clue to tell us what's actually wrong.
Okay, that's interesting. Seems to be kinda useful to know. Okay, let's repeat this for a while.
Now, the next step and the next tip is pretty obvious. When the editor is giving you an error or when the console is giving you an error, fix the errors before you continue. Now, this is a little bit easier when you're dealing with errors in the editor because it'll actually highlight to you the line that's broken. So here we've got a print statement, and when we
Okay, this if statement has not been intended, which means this if statement is useless, doesn't make any change. And if we run this stupid code and silly code, we're just gonna get this printed without catching any case. So both of them are gonna be printed right away. Okay. If we commented out this one, but we just actually intend this, and we could do it so much precisely for the interpreter with 4 spaces, like 1, 2, 3, 4, and that should be just fine. Good, hold on, I'm gonna say my age, and we need an S string over here like that. Boom, is our age, easy.
When we hover over it, it tells us that it expected an indented block. So that should be a good enough clue to tell us what's actually wrong. So if we go ahead and indent this block, then that error goes away. But that's not the only error, no. When you run this code, you still get another error. So let's say that I am a 12-year-old girl. We get another error. And this error does not show up when we write the code, but it only shows up depending on what input we gave to this age variable.
Okay, so she just gave in, could make this a little bit sophisticated. Could make a list that counts, for example, age list. It's pretty easy to fix this. So we're gonna make an empty list, and for example, if you have inputted I am 1 year old, I'm gonna just input this as n, which is or the 0. So this is the 0 year, and nobody's 0 years. So if you have said I am 1 year old, for example, like 1. Okay, so the index of 1 is actually 1 in this, so we could extract the index of this list. So age.list dot index, and then we are going to input that, etc, etc. So it's unnecessary, it's a little bit silly, it doesn't matter. But you could actually make a reference. If you have typed a string, we could check our list and translate it into an integer. So it's not a big deal, I guess.
So now we have a different type of error. We have an error that's in the console. How do we solve this error? Well, the easiest way is just to select the parts of the error that's not specific to your code,
such as this part where it says 12 or our actual line of code. So if we go ahead and copy this part of our error and go into Google and paste it into the search box, and then we add our Python programming language, we should be able to figure out what is going on. So here is the exact same error that we have, and we have 17 answers explaining to us what could go wrong. And in this case, it says the error message means that the string provided to this int conversion could not be passed into an integer. So it couldn't be turned into an integer. And of course, the computer doesn't know how to turn 12 into the actual number 12, because you might have used even a different language. You might have used French, or you might have used German, right? So this doesn't actually work. And that should give us enough of a hint to know exactly what is going on.
So rather than giving you the freedom to choose and give your input, no, sorry. We are going to limit your input only to integers, or by using GUI, maybe. And just like that, we don't have to worry for you to give us a string as if it were describing your age, okay? So most of the time, you're not gonna fall into this rabbit hole, so
Now, of course, the easiest way is we could just tell the user to not do that. Tell them to actually type numbers, and then we don't end up with that problem. But inevitably, things might happen down the line. People might do something that is unexpected. So given that we have this weakness in our code, how can we actually fix it?
Could catch the error. Okay, there is a mechanism in Python. Okay, I'm just gonna ask a guy real quick a very silly question about syntax. How to catch an error in Python. For example, a user inputted the wrong data type. So we're gonna use a while loop. So while true, we're gonna try whatever our code is, okay? And if the if statement was successful, we're gonna break the while loop. If that didn't happen, please try again. That it seems out of reasonable range, okay? Expect value error, then we're gonna use, after we have made our code, which is this while loop. It's not necessary that we use while loop. I don't think so. So we could try this piece of code, and if an error happens in this code, we have already expected an error, okay, and then we're gonna catch it with this print statement. Okay. Was not a valid whole number, please try again. So we're gonna catch the input. Easy peasy. So after we have been inspired, okay, so we're gonna use a column, try. Then we're gonna indent all of this. Then we're gonna expect an error. Expect value error, exactly. And then we're gonna use an F string for the age. You are too young, okay? You have and not. You have entered an invalid age. Try using an integer value, for example, like that. Invalid age. And then I'm going to use the square brackets, curly brackets, sorry. And I'm going to just input that right away. Beautiful. So if I said blah, blah, blah. name age is not defined. Interesting. Should we use the global? Maybe? I don't know. Global. I'm gonna import age. Beautiful. Let's see. Name age is prior to the global declaration. Okay, no problem for that. So I'm just gonna go and delete all of this. Not a problem. So if I type this, you have entered an invalid age, try using integer value. So we're gonna expect that error. And yeah, beautiful. Easy. So that's how you catch errors in Python.
Fix our code to make it more durable. Well, one thing that I want to introduce you to for the first time here is the try except block. So we can catch an exception using Python code. So the way that it works is we know that the potential error is something called a value error. So we can catch that error so that it doesn't crash our code. And
for example, if we went back to this code of block in here, step 2, exactly. And if the code was the same as beforehand, we could, for example, catch this error as well. Why not? Let's do it. Okay, we're gonna indent all of these pieces of code. Beautiful. Then we're gonna expect this. It's not gonna be a value error. It's gonna be out of range error. Okay, what was the name of that error? So I'm gonna run this real quick. We're just gonna reverse all my commands real quick. Beautiful. I'm gonna make this error produce all the time. So it's an index error. Beautiful. So the name of this error is an index error. Okay, so I could just input my code over here, try. Could indent all of this to it. And I could expect this error, which is index error. Yeah, exactly. And I could print it did not enter an integer. Or maybe we could print the index is out of range. This doesn't make any sense to do it because this message has been made for the not end user but for the developer, and doesn't make any sense. You could actually just edit it from your code editor. So yeah, look at this error. Beautiful mechanism in it.
Provide an alternative pathway for our code to go down. So the way that it works is we take the line of potentially dangerous code, which is this line, where we convert a string that the user types in into an integer. And we've seen that that is what's causing this error here. So we take this line of code and we trap it inside a try block. So just the keyword try plus a colon, and then we indent this block of code to put it inside. So now we've got a try block. The next part is we need to add the except keyword and then add in the exception that we want to catch. So in this case, it's a value error that we're getting, and so that is what we're going to be catching. So now inside this except block, what we can do is we can say, well, what should happen if we end up with this error? So where the user types in something that we actually can't convert into an integer. Well, let's first print something to tell them this is what's going on. For example, you have typed in an invalid number. Please try again with a numerical response such as 15. So now we're giving them a little bit of feedback, telling the user what's going on, and then we can just simply copy and paste this code here so that it runs again and we give them another chance. So now let's run this code again.
That's why we are using a while loop. Interesting. So rather than repeating the code and giving you another chance, we could use a while loop to catch the error. So if we went back to Google, we should make all this into a while loop. And if we had the expected output, then hold on a second, I'm just gonna go make some indentation for myself. Okay, new line, so while true. And if we got this case, then we're just gonna break. And if we got another case, for example, if age was actually below 18, then you can drive, then you cannot drive at age whatever. And if we got our expected output, then it's good. Okay, so if I said I am 18, it doesn't make sense in that manner. So if you're 18 or equals, then you could drive, no problem. So I'm 18, you can drive, and it exits. As simple as that. If I wrote 18 like this, you have entered an invalid age. Try using integer value. Let's type like an integer, like numerical. Whatever. I don't care about the spelling. Try using a numerical value like 18. Okay, so we are giving him a little hint to, bypass our code. I'll type 19, for example. You can drive at age 19. Simple as that. And if he gives a wrong value, we are giving him another chance. And he could just type his code and it functions as it's supposed to be. So yeah, that's why we use a while loop when we try to catch an error. Okay, beautiful. So let's continue.
And try with our previous offending code. And now you can see that we get our print statement giving us clear feedback, what's wrong. And then it asks us, how old are you? And now we can type in a number and continue our program as normal. So it continues running instead of stopping our program and crashing it. But remember that solving the errors don't always solve all of your bugs. Like this. In this case, there are no errors with my code whatsoever.
Yeah, there is no errors, but we forgot the F string. And the interpreter is gonna consider this as a whole, a string rather than a variable integrated in a string. Okay,
It's just not doing what I want it to do. And these are the most frustrating bugs to debug because nobody is helping you here. There's no errors that you can Google. There's no underlines that you can check. You actually have to rely on your skills as a programmer to fix this. So pause the video and see if you can fix the code so that instead of displaying the name of the variable, we actually get the value of the variable. Pause the video now. Now we, of course, know that this needs to be an F string in order to insert that variable into this position in the curly braces. But if you didn't, then this would be a lot harder to debug. Experience comes in really handy with debugging, and the more bugs that you solve, the better you get at it. So go onto the internet, try to help people on Stack Overflow, go on to the Discord channel for the course, try to solve other people's bugs, and you will find yourself getting stronger and better day by day.
Yay.
Now, the next tip has been the thing that you've probably been screaming out for. Why don't we use print? And indeed, you are correct. Print is basically your best friend. Now, as developers, I know we don't have a lot of friends, but at least we can rely on print to be our trusty friend.
Best friend.
Do you have heartbreak? Use print. Now, print probably can't help you with your relationship issues or family issues, but it can help you debug your code. And now I'm sure you're pretty much dying to use print to solve these debugging issues. Why, Angela? Why haven't you been using it before? Well, I've been saving it for this perfect moment. So here we've got a very simple program that figures out the number of words in a book. Words starts out at 0, and we have to input the number of pages in our book and the number of words in our book. And then we multiply the pages by the words to calculate the total number of words in the book, and then we print it out. But if we have a go, you can see that, let's say we
Okay, so I'm gonna need some data, and now I'm taking it as a prompt. Not ideal, but no, not a big problem. We could actually use farm some data, store it in a database, and try to analyze it through these type of algorithms. Makes sense.
have 45 pages making a booklet, and we have 250 words per page, and we get 0. So the output that's supposed to tell us that.
So here we are taking 2 integers, and it should work actually. For some reason it doesn't. Kinda unique. Here we have word per page. Why are we setting this to 0? Why? For which reason? Doesn't make any sense. Why are we using 2 equal signs? That's not equivalent. We are trying to assign this. Okay. If we have 56, the number of pages is gonna be 2. So it's working like butter. So yeah, easy to debug without the print statement. Could we skip this? Nah, we're gonna see how we could use the print statement to debug this rather than using the our logic, our paired logic. Okay.
The total number of words in the book ends up being 0. So what's going on here? How can we debug this? Let's go ahead and use print. Take a look at the code and see if you can use print as your friend to help you solve the issue. Pause the video now and give that a go. What are our assumptions? Well, we're actually getting the number of pages and the number of words correct so that we can calculate this. Why don't we add some print statements before the final one? Let's print what's the actual value of some of our variables that we're getting from the user. For example, I could say the pages equals, and then insert the pages variable in here in an F string. And I can also print my other variable in an F string, which is the word per page variable, and this is equal.
We are not updating the variable because we are using this double equal signs, which means we are comparing the value of this variable, which is 0, to this value. And we are not having an if statement, so we are not catching this case, so we are not doing anything with this at all. It doesn't make any sense.
Equal to, let's insert that variable as well. And now when I run my code, I've got my print statements going and I can test it out. So we've still got 45 pages and then 250 words per page. And now you can see that my variables are logged. So this one, this pages variable, does equal 45. so it captured my data correctly, but the word per page equals 0, which is not what I entered at all. I entered 250, so I was expecting this to be 250. So now, using print, my best friend, I've managed to narrow down the problem. It's something to do with this variable. So let's take a look at what's going on here. Well, I've spotted the problem. Have you? Pause the video and see if you can fix this code so the final total number of words actually gets printed when you run the code. Pause.
Yeah, so we're gonna just skip right now. This was very basic, this chapter. Seems to be very easy as well. Here we have just coding exercises and little motivational video. So this is just a little warm-up. And this is the last beginner video, our chapter. Here we have higher, lower game project. And after that, we're gonna start the intermediate section. I'm very excited to do this tomorrow. Today, this chapter plus this one is gonna be kind of enough. Okay, because here we're gonna develop a game that's gonna take a lot of time. And we're gonna start learning about local development, environment setup, and the coffee machine, etc. Object-oriented programming. This is a very mandatory and principle that we have to learn. Very mandatory. Without it, you cannot actually maintain thousands of codes, lines of code. So this principle, you should apply it. Okay, it's like saying to all the developers in the world to how they should organize and structure their code. So to orient the programming, so it is easy to maintain, easy to read, easy to debug, easy, you know what I mean. Then we have after the intermediates, we had the web foundation. So we're gonna learn some HTML, CSS, etc. Intermediate plus, which is a little bit advanced. We're gonna learn about web scraping, which is a very interesting tool. We're gonna add that to an AI agent, and I do have a tool that right over here, Robin, that scrapes the dark web for you, or the deep web. Dark web or deep web, what matters. It depends on your keywords, but it scrapes that onion sites. Okay, and it uses an AI agent to structure the results, and the same principle goes for NaN and how you could, you know. So, you know, learning this skill is going to be very awesome, and a lot of advanced here. We have blog capstone project, make post requests with Flask. Okay, oh, this is interesting. My top 10 movies, websites, databases with SQLite. Okay, this is actually very interesting. Here we have professional portfolio projects, Python scripting, Python web development. Oh my god, look at this. We have here 0 minutes. We have only assignments in here, which means that we have mastered the foundation at all costs. So here 9 minutes, 1 hour, GitHub version control, etc. So in this section, it is all just assignments, which means we're gonna have here some very, very interesting projects and live streams. And you know, after this, we're gonna just free ourselves and start, you know, developing our own products and learning something new. Who knows? So yeah.
Pause the video now. All right, we've narrowed down to this one.
Okay, we're gonna skip this because it's very basic, unnecessary.
Now, before you start getting really committed to print and start making friendship bracelets for this print statement, there's another tool that I really want to talk about. And it's a tool that's bigger, it's fancier, it's more complex. So what is it? It's a debugger. And we've already seen debuggers a little bit.
Yeah, we have played with Thony, which is a very, very beautiful debugger. And easy to play with. So yeah.
So I've already shown you pythontutor.com, and you've also seen us use the debugger in the Thony editor right here.
Yeah.
Now, in the starting code, we have a function called mutate that takes a list as the input and then prints another list at the end. So what happens is
Mutate. It reminds me of mutation that happens in DNA. Interesting. And interesting. Let's debug this. We are importing literally nothing in here. Okay, so I define this and takes this input as a list, and we gave it a list. Makes sense. We have here b list, which is empty, and we are starting the counts from this new item. So for item in a list, so in this list, for example, so the first item is going to be 1. Okay, so the new item is going to be 2 in this case, and then we are adding a random integer. Let's say we are adding 1 to it. We're just going to make the result 3. Okay, so make an equal sign as the result. Okay, and for this new item, we're gonna make this math module. So maybe we should import that. Okay, so we are importing. Okay, so that's already imported. Beautiful. Dot add. So we're using this add statement, which is the add operator. So we are adding 3 to the basic item, which is 1 that we have started with. We're going to make the results as 4. Hold on a second. Come on. The result's going to be 4. And then we're going to add this new item, which is 4, to this empty list. And then we're going to print the list with this item, and we're gonna do all of this throughout this list. Okay, this seems to be fine. It's gonna give us a good output. Interesting. It's kind of interesting, isn't it? Well, we are appending only 1 item, so let me just make that into the for loop. And then we're gonna have this made to these all of these lists. Okay, beautiful. Okay, so it functions just fine. So what we should do in here? It does the thing that it should do, right? So most EDE's intelligent development environments, such as PyCharm, will have built-in tools for debugging. This is normally known as debugger in many ways. They are like print statements on steroids. Okay. So we have body builder print statements. Interesting. Debuggers allows us to peek into our code during execution and pause on chosen lines to figure out what is the inner mechanism and where it's going wrong. There are a couple of things that are the same in most EDEs which you should be familiar with. Breakpoints. You can set a breakpoint by clicking on a line in the gutter of the code. Where the line numbers are, this line will be where the program pauses during the debug run. Step over. This button will go through the execution of your code line by line and allow you to view the intermediate values of your variables. Then we have step into. This will enter into any other modules that your code references For example, if you use a function from the random module, it will show you the original code for that function, so you can better understand its functionality and how it relates to your problem. Step into my code. This does the same thing as step into, but it limits the scope to your own project code and ignores the library code such as random. Okay, that's interesting. So for the first pause, use the PyCharm debugger to figure out what is the issue in the starting code and fix it. So we have fixed the issue with our bare logic by just reading, you know what I mean? Okay, let me check if there is debugger in here. Okay, there is no debugger. Maybe we need to install this as a plugin. I don't know. Services, Docker, blah blah. Okay, here we have the terminal. Okay. Okay, where are the plugins? I don't know. So it has to install this. Okay, here we go. This is the debug. It's already installed. To debug your code, do one of the following. Click the run icon, the editor cutter. Okay, select debug in the editor, context menu. Launch our run configuration. Okay, let's see. Interesting. So we could run it like this, connected to sockets, wherever. Okay, let's see the course, how she uses these
So we
tools.
start out with this B list being an empty list, and we have a new item that starts out being 0. Then we loop through each of the items in the A list that comes in through the input, and we multiply it by 2 and turn that into the new item. And then we modify the new item even further by adding to it a random number between 1 and 3. Finally, we use a function called add in our maths module, which we created right here, and it does the simple thing that you created before, which is just to add one number to another. So we add the new item that we've got up to now to the item that we're currently looping through, and finally we add it all to our B list, and hopefully we are able to modify the A list with this step-by-step approach to end up with a new list where each of the numbers is modified according to our rules. Now, unfortunately, at the moment, it does not do what we expect it to do. It just prints out a single number in a list. So in order to debug and figure out what is wrong with our code to be able to fix it, we're going to cover how to use the debugger in PyCharm. Now, debuggers are pretty similar in most of these intelligent development environments, such as PyCharm. So I'm going to use this opportunity to show you a lot of things that will be reusable even if later on down the line you choose to use a different code editor. Now, what we do first is we can define what's called a breakpoint. So a breakpoint can be created in the gutter of our code, and you might have done it accidentally before. So
Oh
when
yes,
I hover over
I did
the
it
line-
by accident. I did this completely by accident so many times. Okay, beautiful. So, so this is the breakpoint. Interesting. So this is gonna be our first breakpoint, because this is not intended in the for loop, which makes the code not as functionable. Okay. What if we did this? So we have A list, B list is empty, item is equivalent to 13, and the new item is equivalent to 40. Okay. And here we have special variables. Man, this is crazy. How much of things do we have in here? Okay, so we have int 1, int 2, 3, okay, 5, 8, 15. Interesting. So this is the A list. And this is the index 0, index 1, index 2. Value for range of time, okay. The B list is empty. Indeed, protected attributes. That is kind of empty as well, okay. Here we have the item, which is, we are grabbing the last item, which is 13. Yeah, makes sense. That makes sense. True. What is this? gbook tax.by is running, stop and rerun. Okay, interesting.
Numbers in the gutter, you can see this red dot appears. And if I decide to go onto line 9 and click on that red dot, I've now created a breakpoint. And you can see that breaking line is now highlighted. So now I'm going to...
Okay, so I'm gonna learn about this. I'm gonna take a little break, cover some of my energy, and we're gonna learn about the debugger in PyCharm. I guess the same technique goes for other IDEs. For Vim or NeoVim, I don't know how the debugger there functions. Maybe there is no debugger, I don't know. I'm gonna learn about that as well. Straightforward, because I'm willing to use Vim or NeoVim after finishing these beginner projects, because after that I'm just gonna make a directory and my system files. It's gonna be specialized for projects like these in Udemy, and we're gonna use Vim or NeoVim to as an IDE, which is open source, customizable, and so way better. That's why. And we're gonna learn more about realistic projects. Okay, rather than using these GUI oriented IDEs, we're gonna use the terminal IDE, which is way better. And yeah, that's what I'm gonna do. So I'm gonna take a little break. We're back. We're back. We're back. We're back. Let's go.
To go into the debug run mode by clicking on this little bug here, and it's going to run my current file, and it's going to take into account the fact that now I have a defined breakpoint. So what does a breakpoint do? Well, it basically puts a break on the code at that particular line. So here is where I'm setting the new item from 0 to a new value, which is the value of the item multiplied by 2. Now you'll see a couple of things show up already in line in our code, which is kind of
Okay, that's kind of it's interesting. Interessant.
helpful. It's showing us at this point where the code is at, where we've stopped the code on line 9. The current value of a list is this big list, which we inputted right here. So this is the input for this function, and that's showing up right there. And then it's showing us B list is still an empty list, new item is 0, and item, which is the first item in the A list that we're looping through right here, is equal to 1. So now what we can do is use the first of the step buttons in the debug console. So if I click on this one, which is called step over, what is
okay? There's a console for me as well. Test that out. Okay, so we're gonna make this as the breakpoint. Then we're gonna run this again. Yeah. So here we have step over, step into my code. Okay, that's interesting. So here we go to the random library. Then we have this function randinit, random integer. Okay, we have this self parameter, and then E and B. Then here we have an example, like B is 3 and A is 1. Return random integer in the range A and B, including both endpoints. Interesting. So this is the documentation. Interesting. So yeah. Okay. So the new item is 3. So we have chosen 3 in this case. And then we are taking this function and adding it up, and so on and so on. It's interesting.
What it's going to do is it's going to execute my code line by line, stopping at the very next line. So now that we've executed this line, which we've broken, it's now happened, and we can see that what's updated is the new item is no longer equal to 0, but it's now equal to 2, because we took the item, which is 1, multiplied it by 2, and then set it equal to new item. So new item is now equal to 2 instead of 0. So we can continue stepping over to the next line. And remember that the highlighted line is the one that's going to be executed next, and the line above it is the one that just got executed. So right now we can see that this line 10 has just been executed, and we've generated a random integer between 1 and 3, and we've added that number to our new item. So now our new item is equal to 5. So while we're here, we can do something else. We can look at another one of these buttons. So if I go ahead and rerun my debugger, and I use, instead of the step over button, I click on the step into button. So it's going to continue executing each line as it goes, line by line. But when it encounters a line such as line 10, where we're using another module, so code in another file, such as this randint function from the random module, when I click step into, it's going to go into the definition of that function the randint function in the random module from random.py, which is built into Python. And it's going to show you how that function works. So in fact, randint actually uses another function called randrange. And if I continue stepping into it, it will go and find this function randrange and show me how that function works. Now, once you're done exploring this, which can be really helpful because your code relies on code that's been written by other people, and if you want to know how they've defined it, how they've created randrange, then you can read through their code, and sometimes it can provide helpful hints for us to figure out what is wrong with our code. Now, you don't want to continue stepping through other people's code, so when you want to exit, you click on this button, which is step out, and we can continue stepping out until we get back to the code that we want to examine.
Okay, this is pretty interesting. Just like that, you could step out, you could step over line by line. Well, that's pretty cool. You could step out from everything, right? Not sincerely. And after you stepped out from everything, then we're gonna have an error. Interesting. Oh, that's quite interesting. Kind of interesting though. Okay.
So this can be really helpful where we're stepping through the functions, but more often than not, we don't actually want to step into the library functions such as random because they work the way they do and we can't really modify it. So we probably haven't made a mistake there. And what we want to do sometimes though is we want to be able to step into code that is in other files, but only the code that is written by us. And we want to ignore these library functions written by the Python team. So how can we do that? Well, let's repeat from the beginning. So this button restarts our debug run and again pauses on our breakpoint. Instead of using this step into button, we're going to use the step into my code button, which does exactly the same thing as step into, going line by line, but it ignores the library functions. For example, that random function right there. It doesn't take you over to the random.py file. But now if I click into step into this current line 11, then it takes me into this file that I created, math.py, where I created this function called add. And it shows me that right now I'm trying to add 4 to 2, which was passed over from the previous function call. And if I step out of that add function in the math module, I can go back to examine my file. So this button can be more useful when we have multi-file projects and we're trying to examine the cause and the relationship of what could be going wrong in our code. Because very often, as our code gets more and more complex, there's more and more relations that start happening. And we're sometimes using code that's been defined elsewhere and chasing it around can be quite difficult. So those are some of the most important features of the debugger. And I want you to take a look also down here. We've got two tabs here, the threads and variables and the console. So the threads and variables can be really helpful showing us the values of the variables that we've got going on. So for example, just as they've shown up here as these comments, you can also see them in the list right here. What's the current value of new item at this particular time point? What is the current value of blist at this particular time point? And as you can see that as I continue stepping through my code line by line, these values, they update as they get changed in the code. So we can actually trace what's happening to each of our variables in their intermediate stages. And especially for something like a for loop where everything is pretty much hidden, we don't know what's going on while it's looping, this can be really, really helpful to help us figure out what's wrong with our code.
Sure.
So the other tab here is the console. and you can see that it shows what gets printed during the run of the code. So for example, if I was to get rid of this breakpoint, so I can either disable it by clicking it once and it goes into this darker color, or I can keep it there and simply say mute breakpoints. Now, if we continue running through our code and stepping it through, you'll see that eventually it ends the loop and goes to the print, and we can see that print happening in the console. So we get our console even when we're running in debug mode as well. So that's pretty much all there is to it, to the major features of a debugger. The most useful thing, I think, is just simply being able to see these values show up as you go through the code, stepping through.
Pretty interesting, isn't it?
So
it's kind of true. So yeah, we could actually see these values. Let me just run this again. There we go, we have an empty list. New item is 0. We take the first item from the list, which is 1. Then this is the A list, which we have inputted through all of this. We could step over. Okay, now we have a position for the new item, how it's to, etc. It's pretty neat. Rather than doing it with our bare logic or by just reading, we could use a debugger. That would help us a lot.
So now it's your turn to use what you've learned about the PyCharm debugger and figure out what is wrong with our code. Why is it not printing out an entire list with 1, 2, 3, 4, 5, 6 items, and instead why is it only modifying and printing out the first item in the list? So pause the video and complete this challenge.
Okay, so the error is with this indentation. Pretty simple.
Do another debug list and
just
see
gonna
with
skip.
these. The list is still empty over this line to get print as they're created. So the debugger.
Finally. So this is very basic. We just skip it. Then we have final debugging skills tips. I'm going to do that for tomorrow. So yeah, that's the end of the stream.